Okay, so to start chapter 6, we're going to do a little quick review of ratios and what ratios are. So when we get into chapter 6, we're going to be looking at figures that are the same shape but different sizes. So we're going to be working with proportions and ratios a lot. So just a quick reminder, a ratio, all it is it's a comparison of two quantities. When we talk like miles per hour, you're talking about the quotient, the fraction of the amount of miles you drive over the amount of hours you drive. So you can write ratios a bunch of different ways. So you could say the ratio of A to B, you could write it out in words. You could do a fraction A over B. So the ratio of length to width would be like L over W. If this said the ratio of width to length, we would actually go W over L. Sometimes you'll see ratios written with a colon, with this like A colon B notation. That just means A to B, the comparison of A with respect to B. So to simplify a ratio, that just means to simplify the fraction. And what I mainly want you to do here is just simplify the fraction as much as you can, and then just keep units on. So 12 centimeters to 4 meters, that could simplify to 3. But we don't just write 3, we would say 3 centimeters to 1 meter. This is one of those situations where you would have a 1 on the denominator that you'd want to write because you're comparing two different quantities. 6 feet to 18 inches, you could simplify that to 1 foot to 3 inches, similarly, just keeping the units on there. When it comes to two different figures, we're told the ratio of the sides of triangle DEF to the sides of ABC are 2 to 1. 2 to 1 meaning that every 2 units in ABC, every 2 units in DEF represent 1 unit on ABC. So in other words, all of the sides of triangle DEF are twice as big as that of ABC. So if CA is 3, CA written first and third, that would mean DF written first and third would have to be 6, because it's just double it. If DE is 8, you can ask yourself, what would AB have to be? And the answer would be 4, because it's got to be half as big, just kind of going the other way. If we want to find the lengths of all the sides, though, if we want to find CB and find FE, we don't know what one of those is off the top of our head, but we can find the third side of a right triangle using the Pythagorean theorem. So you could say x squared is equal to 3 squared plus 4 squared. X squared is equal to 9 plus 16, that's 25. So x is 5. If you know your Pythagorean triples and know a 3, 4, 5 is a right triangle, you could have just jumped right to that. But now that we know CB is 5, we don't need to do the Pythagorean theorem to find FE, because now we know we can just double that length because the ratio is 2 to 1 to say that FE has to be 10. Similarly, if you're told the ratio of two sides, for example, in a rectangle, if you're told AB to BC is 3 to 8, and we're wondering what x has to be, I like writing these as fractions instead of using the colon notation. So you could do AB over BC is equal to 3 over 8. And then we can just replace AB here with a 6 and CB with an x. And solve that proportion. So remember, to solve proportions, we cross multiply. We take 3 times x and set that equal to 8 times 6. So we have 3x is equal to 48. Dividing by 3, x has to be 16. You can go ahead and try this one on your own, so go ahead and pause the video, see how you do, but we'll go through it together in a moment. Okay, so if you have EF to FG is 4 to 5, you can jump right to 4 over 5 is equal to, think what's EF? EF is y plus 7 over FG, which is 40. Cross multiply. Now when we cross multiply this, we're going to do 5 times the quantity of y plus 7. Put these in parentheses if you need to, anytime you have a binomial in a fraction. That's equal to 160. So now you could distribute the 5, so 5y plus 35 is 160. So 5y is 125. So y has to be equal to, 25. And that would mean that length would actually be 32. And 32 over 40 is the exact same thing as 4 over 5. So that's why that would work. Let's keep going. If you're told the area of this rectangle is 448 square units, and the ratio of width to length is 4 to 7, how are we going to find the length of each side? Well, the formula for area of a rectangle is length times width. Length would be here, width would be there. So we have to figure out what those are if the ratio is 4 to 7. Well, how we do this is we just introduce a variable. So we'll just call this side 7x and this side 4x, because that means no matter what we put in for x, we're going to keep that proportion. So this could be 8, and that would have to be 14 if x was 2. If the x was 3, we would have 12 to 21, etc. And now to find area, you just multiply those two values. So 448 is equal to 7x times 4x. So 448 is equal to 28x squared. And now we have to talk about how to solve something like this. We'll get x squared by itself. So to do that, we divide both sides by 28. If you don't know what that is off the top of your head, go ahead and take a calculator. You're probably going to need a calculator in this section anyway. We get 16. So x has to be 4. So the length of each side would be 16 by 28. Because 16 times 28 is 448, and that holds this ratio true, 4 to 7. A similar problem here, it's actually a little easier, I think. We're told the perimeter of the rectangle is 320 inches. The ratio of width to length is 3 to 5. So we'll set up this 3x, 5x thing again, where x is just helping us maintain that ratio. That means this side is also 5x and this side is also 3x. So for the perimeter, we just add up all the way around the outside. So 3x plus 5x plus 3x plus 5x is 320. Combine all of our like terms. You get 8x plus 8x, that's just 16x, equals 320. Divide by 16, x is equal to, I think, 20. So the length of each side would be 60 by 150. No, it's terrible math. 60 by 100. There we go. And then if you add 100 plus 100 is 200, 60 plus 60 is 120. Added it all together, you get 320. All right, only two more things to go over. You can also have an extended ratio. So a ratio can compare more than two things. So for example, if you're told the angles of this triangle are in the extended ratio of 1 to 2 to 3, what that means is the biggest angle is 3 times as big as the smallest, and the medium-sized angle is twice as big as the smallest, and then subsequently the biggest angle is 1.5 times the most medium measured angle. So in a triangle, we know the angle sum is 180. So what we can do is we can call this angle 1x, we can call this angle 2x, and this angle 3x, very similar to the last few examples. And then if we want to find what x is, we just add those up. And we combine the like terms, set them equal to 180. So 6x is 180. So x is 30. So this angle here is 30. This angle here is 60. And this is 90. So anytime you're told the ratio and you're asked to find a side length, you're going to want to just introduce an x value. Like this one, and like the first one we did too. In the homework tonight, you have a few problems like this. I would just kind of look over this example again because they all kind of work the same way. And you technically don't even need a picture for a triangle because you know the angles always add up to 180. So you could do something like this. Okay, last thing we're going to talk about, we're actually not going to use a ton in the immediate, but down the road we're going to use geometric mean a fair amount. This is a new term for you. So most of you are familiar with the arithmetic mean. That's like the average. That's where you add up 2 numbers and divide by 2, or you add up 10 numbers and divide by 10. The geometric mean, we're going to see its applications not today, but we're just introducing the idea today because it deals with fractions and proportions. But the geometric mean between two numbers, call them A and B, whatever they are, is a positive number x that this proportion is satisfied, where you have A over x is equal to x over B. What ends up happening here is when we cross multiply, we get x squared is equal to AB. So in general, x is just equal to the square root of the product of the two numbers that you're taking. So if you want to find the geometric mean of 8 and 18, you can do 8 over x is equal to x over 18. So x squared is equal to 144. So x is just 12. And notice that's different from the arithmetic mean. The arithmetic mean of 8 and 18 is the number right between the two numbers, which would be like 13. The geometric mean is 12. Once again, we're not seeing the application of this today, but we will down the road. For 3 and 27, same game. You can actually jump right to this idea. X is equal to the square root of 3 times 27. So x is equal to the square root of 81, and x is equal to 9. So 9 is the geometric mean of 3 and 27. Definitely not the arithmetic mean. The arithmetic mean would be 15, but 9 is the geometric mean. And that does wrap us up for 6.1.